Hello, and a very gentle welcome to The Sleepy Scientist. Find your quiet space and let your body settle into a state of ease. Allow your breath to slow, your muscles to soften. Tonight, we will not be journeying to the edge of the cosmos or the beginning of time. Our journey will be one of scale, shrinking ourselves down, becoming quiet observers of a world that is all around us, yet mostly unseen and unheard. Imagine, for a moment, that you are sitting on a porch on a warm summer evening. As the darkness deepens, the air comes alive with sound. You can hear the steady, rhythmic chirp of a cricket, a sound so familiar it has become the lullaby of the season. You might see the gentle, intermittent flash of a firefly, a tiny, silent spark in the gloom. We notice these few signals, but what if I told you that these are just the loudest and brightest words in a vast and complex conversation happening all around you? What if the very air you are breathing is thick with invisible messages, with silent words written in a language of scent? What if the vibrations in the soil beneath you are carrying a different kind of story? Tonight, we are going to learn how to listen to this hidden world. We will become eavesdroppers on the secret lives of insects. And in the quiet telling of their stories, perhaps we can find our own path to a deep and peaceful rest. Let us begin our exploration of this hidden world with the language that is most common, most powerful, and yet most invisible to us. It is not a language of sound, nor of sight. It is the language of scent. It is a form of communication so precise and so potent that a single, well-chosen word can travel for miles on the wind to deliver a message of profound importance. This is the world of chemical communication, the world of pheromones. To us, a scent is often a vague and general thing. The smell of rain on dry earth, the fragrance of a blooming flower, the sharp scent of pine in a forest. These are beautiful, but they are a kind of background noise. For an insect, the world of scent is a library of specific, detailed information. A particular scent is not just a smell, it is a word, a sentence, a command. These chemical words are called pheromones. Imagine a single molecule, a tiny, complex structure of atoms, crafted within an insect's body. When this insect wants to send a message, it can release a small cloud of these molecules into the air. This plume of scent then drifts on the breeze, a message in a bottle cast into the great ocean of the atmosphere. And other insects of the same species, with their incredibly sensitive receiving equipment, can detect these molecules even in infinitesimal quantities and understand their meaning instantly and without ambiguity. The variety of this invisible language is astounding. There are pheromones for almost every aspect of an insect's life. There are alarm pheromones. When an aphid on a rose stem is attacked by a ladybug, it can release a small puff of a specific chemical. The other aphids nearby immediately detect this scent-based scream. It is a silent chemical shout that says, "Danger, flee." And in response, they may drop from the plant to escape the predator. The message is simple, urgent, and life-saving. There are aggregation pheromones, which tell insects to gather together. Certain types of bark beetles, for instance, when they find a suitable tree to infest, will release a pheromone that calls their brethren from all around. It is a chemical invitation that says, "Come here. This is a good place." This allows them to overwhelm the tree's defenses with their sheer numbers. And of course, there are pheromones for what is perhaps the most fundamental drive of all finding a mate. These sex pheromones are some of the most potent and specific chemicals in all of nature. A female moth, ready to mate, might release a particular pheromone, and the male of her species, even miles away, can detect this airborne love letter and follow it back to its source. It is a romance conducted entirely on the currents of the air, a relationship built on a language we can never smell. To truly appreciate this world, we must try to imagine what it would be like to live within it. Imagine if human emotions had a distinct scent. If the feeling of joy released one type of molecule into the air, and the feeling of sadness released another. Imagine if you could write a message, not with a pen, but by releasing a specific chemical, and your friend across town could receive it and understand it. This is the everyday reality of the insect world. It is a constant, swirling, and invisible conversation. The organs that insects use to read this language are most often their antennae. We tend to think of antennae as simple feelers for touching things, but for many insects, the antennae are, in fact, incredibly complex and sensitive noses. The surface of an antenna can be covered in thousands of microscopic, specialized receptors, each one shaped to perfectly match and bind with a specific type of pheromone molecule, like a key fitting into a lock. When a single molecule of the correct pheromone bumps into its corresponding receptor on an insect's antenna, it triggers a tiny electrical signal, which is sent to the insect's brain. The insect doesn't need to detect thousands of molecules. In some cases, detecting just one, or a handful, is enough to get the message. This is a level of sensitivity that is almost impossible for us to comprehend. It is the ability to find one specific grain of sand on an entire beach. This chemical language is both robust and ephemeral. It can travel great distances, and it can linger in the air or on a surface for a time, leaving a message for those who come later. But it also fades. The wind disperses the molecules. Sunlight can break them down. The message is often temporary, a language perfectly suited for the present moment. So, as you lie here, breathing in the quiet air of your room, know that the air is never truly empty. Outside, it is a medium for communication, a swirling tapestry of these invisible words, a message of danger from a threatened bee, a scented invitation from a lonely moth, a chemical trail leading to a hidden source of food. The world is alive with a silent, fragrant conversation, a complex and ancient language that has governed the lives of insects for millions of years. To truly understand the power of this language, it is not enough to speak of it in general terms. We must follow one of these conversations. We must shrink ourselves down and follow a single insect as it writes its message upon the world. And there is no better place to start than with one of the most familiar and industrious of all insects, as it lays down a fragrant path for its sisters to follow. Let us go now and follow the story of the ant. We have opened our minds to the possibility of a world that communicates through scent, a language of invisible words carried on the wind. We have learned that the air around us, far from being empty, might be filled with these silent, chemical conversations. To truly grasp the power and elegance of this language, we must now become observers of a specific dialogue. We will shrink ourselves down, become quiet witnesses on the forest floor, and follow the story of one of the most masterful users of this scented language, the ant. Imagine a small, bustling city, its entrance a humble opening in the earth. This is the ant nest, a complex subterranean world of tunnels and chambers, home to thousands, perhaps millions of individuals. The entire colony operates as a single superorganism, a collective being with one shared purpose to survive and to thrive. And the lifeblood of this great organism, the communication network that holds it all together, is a complex vocabulary of pheromones. Let us focus our attention on a single worker ant. We will call her the forager. She emerges from the darkness of the nest into the bright, warm world above. Her mission is simple: to find food for her sisters and the queen. She sets out, her tiny antennae twitching, constantly tasting the air and the ground, reading the subtle chemical cues of her environment. Her initial journey may seem random. She navigates around a giant pebble, climbs over a fallen leaf that is like a mountain to her, explores the terrain with a tireless, determined energy. For now, she is alone. After a long journey of exploration, she finds a treasure. Perhaps it is a small crumb of a cookie dropped from a picnic blanket, a single crystal of sugar shining like a diamond in the sun. For her, this is a mountain of pure energy, a discovery of immense importance to her colony. Her first instinct, after examining the prize, is not to feast alone. It is to share. It is to go back and tell the others. But how she cannot shout? She cannot draw a map. Instead, she will use her own body as a pen and the ground as her paper. She begins her long journey back to the nest. And as she walks, she engages in a beautiful and deliberate behavior. Every few steps, she briefly touches the tip of her abdomen to the ground, releasing a microscopic, almost immeasurable droplet of a very specific chemical. A trail pheromone. Walk, touch, walk, touch. She is not leaving a visible trail. She is leaving a trail of scent. She is creating a fragrant road, a chemical map that only her sisters will be able to read. Each droplet is a breadcrumb, an invisible signpost that says, "This way, follow me. I have found something wonderful." She finally arrives back at the entrance to the nest, her prize perhaps carried in her mandibles. Her arrival creates a stir of excitement. She communicates with her sisters through touch, tapping them with her antennae, sharing samples of the food she has found. She is, in effect, shouting with both taste and touch, "I have found a great treasure. Follow the path I have made." And now, a new wave of workers is recruited. They emerge from the nest, their mission now clear. They do not wander randomly as our first forager did. They are searching for something specific. Their antennae tap and sweep across the ground, tasting the chemical landscape. And then, one of them finds it. She detects a molecule from the scented trail. It is a perfect match for the receptors in her antennae. The message is received. She has found the road. She locks onto the trail, following the invisible line of pheromones with remarkable precision. She and her sisters move in a determined column, turning where the trail turns, navigating the complex terrain by following this simple, fragrant guide. It is a highway of scent, as clear and as obvious to them as a brightly painted line on a road is to us. They arrive at the source, the mountain of sugar. They each take a piece and, just like the first forager, they begin their journey home. And here is where the true genius of the system is revealed. As each of these successful ants returns to the nest, she also reinforces the trail. She adds her own droplets of the same pheromone to the path. Walk, touch, walk, touch. The scented road becomes stronger. What was once a faint whisper of a trail, laid by a single ant, is now a chorus. The concentration of the pheromone increases. This stronger, brighter trail is now easier for other ants to find, and it signals to them that this is a very profitable path. A stronger trail attracts even more ants, who in turn find the food and reinforce the trail further. It is a positive feedback loop, a brilliant system of recruitment that allows the colony to quickly mobilize a massive workforce to exploit a rich food source. The single-lane country path has now become a bustling, multi-lane superhighway of scent. But what happens when the treasure is gone? What happens when the last crumb of the cookie has been carried away? The system is just as clever in its ability to forget as it is in its ability to remember. The returning ants, finding no more food, no longer have a reason to reinforce the trail. They stop laying down the pheromone on their way home. And the pheromone itself is designed to be temporary. It is a volatile chemical. This means it evaporates, warmed by the sun, blown by the breeze. The molecules of the scented trail begin to lift off the ground and disperse into the air. One by one, the chemical breadcrumbs vanish. The road begins to fade. As the trail weakens, fewer ants are attracted to it. The great highway thins out to a small road, then a faint path, and then it is gone completely, leaving no trace. It is like a dream that dissolves upon waking. This ability to forget is just as important as the ability to create the trail. It prevents the colony from wasting its precious energy and workforce by sending thousands of ants on a dead-end mission. The map only exists as long as it leads to a worthwhile destination. When the destination is gone, the map erases itself. Let us pause and marvel at this. There is no leader, no general, no architect with a grand blueprint. There is no one ant giving orders. The entire complex and incredibly efficient foraging behavior of the colony emerges from a few Very simple rules followed by each individual ant if you find food. Leave a trail on your way back. If you smell a trail, follow it. If you follow a trail and find food, reinforce the trail on your way back. From these simple local interactions, a kind of collective intelligence is born. The colony, as a whole, behaves like a single, intelligent mind, capable of solving complex problems, all through a language written in a vocabulary of scent. So, the next time you see a line of ants marching with such purpose across a sidewalk, know that you are not just seeing insects. You are seeing a physical manifestation of an invisible conversation. You are seeing a community bound together by a shared chemical map, a story being written, read, and rewritten, moment by moment, on the ground beneath your feet. We have walked beside the industrious ant, marveling at the scented map it writes upon the world, a language of trails that builds highways of collective purpose. It is a story of community, of cooperation, of a language written on a solid surface. But now, our journey into the invisible world of insect communication must take to the air. We will leave the deliberate, grounded conversation of the ant trail and explore a message that is designed to be broadcast, to be cast upon the wind like a dandelion seed, a message of pure, focused, and profound romance. This is the story of the moth and the molecule. Let us imagine a quiet, moonless night in a temperate forest. The world is a tapestry of deep shadows and soft, silvery starlight. On the underside of a broad oak leaf, a female moth rests. She is a creature of stillness. Her wings, perhaps patterned like the bark of the tree, are folded, making her almost invisible. She has recently emerged from her cocoon, and her life as a winged adult is a brief and urgent one, driven by a single powerful imperative to continue her lineage. And so, she begins to call. Her call is not a sound. It is a perfume. From the tip of her abdomen, she begins to release a tiny, invisible cloud of a highly specialized chemical, a sex pheromone. This is not just any random scent. It is a complex molecule, a unique chemical signature that is specific to her species. It is her name, her species, and her desire, all encoded into a single type of molecule. She releases it not as a constant stream, but in gentle, rhythmic pulses, creating a plume of scent that is now caught by the gentle currents of the night air. Imagine this plume as a ghostly, fragrant river, flowing out from the leaf and meandering through the forest. As it travels, it thins and disperses. The farther it gets from its source, the more diluted it becomes. The molecules, once a concentrated cloud, are now spread farther and farther apart. Individual messengers floating alone in the vast ocean of the air. It is a love letter written on the wind, a promise sent out into the darkness with no guarantee it will ever be read. Now, let us travel with this invisible river of scent. Let us journey far from the oak leaf, perhaps a mile or even several miles away. Downwind. Here, another moth is stirring. This is the male of the same species, and he is a creature built for one purpose: to read the message that is now drifting toward him. Look at him. His body may be small, but his most prominent features are his two magnificent antennae. They are not simple, whip-like feelers like those of a beetle or an ant. They are great, feathery, fern-like structures, incredibly intricate and complex. They are bipectinate, meaning they have branches coming off a central stalk, like the structure of a feather. This design is a marvel of natural engineering, its purpose being to create the maximum possible surface area. These antennae are not designed for touching. They are designed for sifting the air. They are living nets, crafted to catch a single specific type of molecule. The male moth rests, and his great feathered antennae are constantly sampling the air, tasting the millions of scent molecules that drift by the scent of damp earth, of decaying leaves, of night-blooming flowers. His brain is programmed to ignore all of these. They are just background noise. He is listening for one particular note in this complex olfactory orchestra. He is waiting for her specific chemical song, and then it happens. A single molecule of the female's pheromone, having traveled a mile on the breeze, by pure chance, bumps into one of the fine hairs on his antenna. On that hair is a receptor, a protein molecule shaped with the precision of a keyhole, a lock that only this one specific molecular key can open. The molecule binds to the receptor, and in that instant, a tiny electrical signal flashes down a nerve and into the male moth's simple brain. The message is received. It is not a complex thought. It is a jolt, an undeniable, all-consuming command. It says, "She is here. She is out there." The detection of this single molecule triggers an immediate and profound change in his behavior. His apathy vanishes. He is filled with a singular purpose. He does not know exactly where she is. The single molecule does not provide a map, but it provides a clue. He knows the general direction the wind is coming from, and so he takes flight. He does not fly randomly. He flies upwind into the breeze toward the source of the scent. His flight is a beautiful and complex ballet of navigation. As long as he is flying upwind and his antennae continue to be struck by her pheromone molecules, he knows he is on the right path. The ghostly river of scent is growing stronger, the molecules more concentrated. If he loses the trail, if he flies out of the narrow plume of scent, the signals stop. He immediately changes his behavior. He begins to fly in a zigzag pattern, casting back and forth across the wind like a sailboat tacking until he finds the edge of the invisible river again. Once his antennae detect the molecules once more, he reorients himself and continues his determined flight upwind. Imagine his journey, a tiny, winged creature, flying for miles through the dark and dangerous night. He is guided not by sight, but by a force he cannot see, an invisible chemical thread that connects him to a mate he has never met. He navigates a three-dimensional world of obstacles, of looming trees and tangled branches, of potential predators like bats and owls, all while keeping his senses tuned to this one, faint, airborne promise. It is a quest of incredible perseverance, a pilgrimage driven by a message in a bottle. As he gets closer to the source, the concentration of the pheromone becomes exponentially stronger. The faint, ghostly river has become a fragrant flood. The signal is no longer a few molecules every few seconds, but a constant stream. He can now use the subtle differences in the signal strength between his two antennae to pinpoint the source with incredible accuracy. He is no longer just flying upwind, he is homing in on a beacon. And finally, he arrives. He finds the oak tree, the specific leaf, and he finds her, the silent, patient source of the call he has followed so faithfully. A romance that was initiated across a vast distance of dark forest has been consummated, its entire dialogue conducted in a language that is utterly imperceptible to us. It is a communication of absolute precision and staggering sensitivity. This airborne love story is one of the most powerful examples of the specificity of the pheromonal language. The male moth is not attracted to the scent of any other species. His receptors are tuned only for the pheromone of his own kind, ensuring that his incredible energy-intensive journey does not end in a futile meeting. It is a perfect private communication channel, a whispered secret shared between two partners, carried on the silent currents of the night. We have spent our time together immersed in a world of profound silence, a world of invisible words and airborne romance. We have followed the fragrant map of the ant and the perfumed love letter of the moth. We have come to understand a language that speaks without sound. But now, it is time for our journey to enter a new dimension. It is time to open our ears and listen to a conversation that has been the soundtrack to warm evenings for millions of years. We are going to explore the language of sound, and there is no better place to begin than with the familiar, comforting, and rhythmic song of the cricket. Imagine yourself once again on a peaceful summer night. The heat of the day has subsided and a gentle coolness settles over the land. And as the darkness deepens, the symphony begins. from the tall grasses, from the shadows of the garden, from beneath the porch steps, a steady pulsing chirp rises to fill the air. Chirp! 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 It is a sound so deeply associated with summer nights that it almost becomes a part of the silence itself. It is a sound of peace, of tranquility, a natural lullaby. But have you ever stopped to wonder what exactly that sound is? We hear it as a single collective hum, but it is, in fact, the combination of dozens, perhaps hundreds, of individual voices, each one telling a specific story. And how is this sound made? A common thought is that crickets rub their long legs together, like a tiny violinist. But the truth is even more intricate and beautiful. A cricket does not play its legs, it plays its wings. The sound of a cricket's chirp is produced by a process called stridulation. It is the act of rubbing one specialized body part against another. Let us look closely at the forewings of a male cricket. One wing is equipped with a thick, hardened edge that acts as a scraper. The other wing has a surface covered in a series of tiny, serrated ridges, like the teeth of a file or a comb. To create his song, the cricket raises his wings slightly and pulls the scraper of one wing across the file of the other. Each time the scraper clicks over one of the ridges on the file, it produces a tiny pulse of sound. And the cricket does this with incredible speed, producing a rapid series of pulses that we hear as a single, coherent chirp. He is, in essence, playing his own body like a miniature musical instrument. The wing stachels which carry him through the air have been repurposed into a percussive device, a tiny maraca, designed to send vibrations out into the world. And this is not just random noise, it is a language, with a distinct and varied vocabulary. The song you are most likely to hear on a summer evening is the calling song. This is the loud, clear, and relentlessly repeating chirp made by a male cricket who is trying to attract a mate. He finds a good spot, perhaps near the entrance to his burrow, a place that will amplify his song, and he begins his broadcast. It is an audible beacon, a lonely heart's advertisement sent out into the darkness. It says, "I am here. I am a strong and healthy male of my species. Come and find me." Females of his species can hear this song from a great distance and use it to locate him. But if a female, attracted by this calling song, approaches him, the music changes. The male cricket can sense her presence, perhaps through touch or chemical cues. His loud public broadcast is no longer necessary. He now switches to a different song. A courtship song? This song is much quieter, softer, and often more complex and melodious. It is a gentle serenade, a private conversation whispered only to her. It is meant to persuade her that he is a suitable mate. It is the difference between shouting across a crowded room and whispering in someone's ear. And there is a third type of song in the cricket's repertoire. If another male cricket wanders into his territory, drawn by the same calling song, our cricket will switch his tune again. This time, it will be an aggressive or rivalrous song. It might be a louder, more staccato, or more confrontational series of chirps. It is a sonic duel, a way of establishing dominance and defending his territory without having to engage in a physical fight, which could risk injury. It is a clear message to the intruder. This space is taken. I am here. Move along. So, that steady, peaceful hum of the summer night is, in reality, a complex social drama unfolding in the tall grass. It is a chorus of dozens of hopeful males calling for partners, a few lucky ones whispering their soft serenades, and occasional sharp arguments breaking out on the borders of their territories. It is a city square, bustling with commerce, romance, and rivalry, all conducted through a language of vibration. But how is this language heard? Crickets do not have ears on their heads in the way that we do. Their ears are in a very surprising place, their front legs. Near the knee joint on each front leg, a cricket has a small oval-shaped membrane called a tympanum. This is a thin, drum-like patch of cuticle that vibrates when sound waves in the air strike it. Behind this membrane is an air-filled chamber and a collection of sensory cells that translate these vibrations into nerve signals, which are then sent to the brain. They have, in effect, an ear on each leg, and this placement allows them to detect not just the presence of a sound, but also its direction. By comparing the timing and intensity of the sound arriving at each of its two ears, the cricket can pinpoint the location of the singer with remarkable accuracy. A female can navigate directly toward the most appealing calling song, and a rival male knows exactly where the competition is. Let this new understanding change the way you hear the world. The next time you are outside on a warm, dark evening, let the sound of the crickets wash over you. But instead of hearing it as a uniform, natural hum, try to listen more deeply. Try to pick out the individual voices in the chorus. Recognize that each chirp is a purposeful act, a word in an ancient language. It is a song of hope, a song of persuasion, or a song of warning. You are not listening to background noise. You are eavesdropping on 1,000 tiny, vital conversations. You are listening to the symphony of the summer night, a performance that has been refined by millions of years of evolution into the perfect, peaceful lullaby that now fills the air around you. We have rested in the gentle, percussive rhythm of the cricket's song, a nightly symphony played on the delicate instrument of its own wings. It is a language of chirps, a vocabulary of pulses that speaks of romance and rivalry in the cool of the dark. But as night gives way to day, a new musician takes the stage. A new sound begins to fill the air, not a crisp chirp, but a deep, resonant, and continuous buzz. A sound that seems to emanate from the very heart of the summer heat. This is the song of the cicada. This sound is a different voice, with a different texture and a different purpose. It is not the sound of friction, of a scraper pulled across a file. It is the sound of drumming. It is a deep, vibrational hum, produced by a remarkable and powerful piece of biological machinery. To understand it, let us imagine a male cicada, clinging to the bark of a sun-drenched tree. On either side of his abdomen, hidden beneath his wings, are two special ribbed membranes of cuticle. These are his sound-producing organs, his drums. They are called tymbals. Think of them as being like the small, curved dome on the metal lid of a jam jar. The part that you can press down with a click and that pops back up with another click. Attached to these two timbal membranes inside the cicada's body are a pair of incredibly powerful muscles. To produce his song, the cicada contracts these muscles at an astonishing speed. With each contraction, the timbal membrane is buckled inward, creating a sharp click. When the muscle relaxes, the membrane pops back to its original shape, creating another click. The cicada can do this hundreds of times per second. This rapid succession of clicks, this incredibly fast drumming, merges together in our ears to create the continuous, vibrating buzz that is the signature sound of a hot summer day. But there is another part to this instrument. The cicada's abdomen is mostly hollow, a large, empty chamber that acts as a perfect resonating box. Like the body of a guitar or a cello, the sound produced by the clicking timbals is not just released into the air. It is amplified and given its deep, sonorous quality by this resonating chamber. This is how such a relatively small insect can produce a sound so loud it can be heard from a great distance. A sound that can, in large numbers, dominate the entire sonic landscape of a forest. Unlike the cricket, with his varied songs for different social situations, the male cicada's loud buzz has one primary, all-consuming purpose to attract a mate. It is the cicada's version of the cricket's calling song, but delivered with a singular, deafening intensity. It is a desperate and powerful broadcast, a declaration of his presence and his readiness to continue his lineage. And the urgency of this song is rooted in the cicada's incredible life story. The buzzing, winged creature we see clinging to a tree is only the final, brief, and glorious chapter of its life. For most of its existence, the cicada has been living a secret life underground. It began as a tiny nymph, hatched from an egg laid in a twig. It fell to the ground and burrowed deep into the soil, where it would spend years, sometimes many years in the darkness. It would feed on the sap from tree roots growing slowly, silently, waiting. There are annual cicadas, whose nymph stage lasts for 2 or 3 years, with some emerging every summer. But there are also the periodical cicadas of North America, one of the great wonders of the insect world. These cicadas have life cycles that are synchronized to an astonishing degree. They spend exactly 13, or in some cases, 17 years underground. Imagine that. 17 years of slow, patient, silent growth in the total darkness beneath the forest floor. A creature biding its time, waiting for a signal that is written into its very genes. And then, in one specific spring, the 17th spring, a great silent alarm goes off, triggered by the soil reaching a specific temperature. Millions, sometimes billions, of these nymphs all begin to tunnel their way to the surface at once. The emergence of a periodical cicada brood is one of nature's most spectacular and overwhelming events. Over a period of a few days, the ground of an entire forest will be riddled with holes, and these large, prehistoric-looking nymphs will crawl out of the earth where they have been buried for nearly 2 decades. They climb up the nearest vertical surface, a tree trunk, a fence post, a blade of grass, and there, they perform their final molt. Their nymphal skin splits down the back, and a new creature emerges, a winged adult, pale and soft at first, but soon its body hardens and its wings unfurl, ready for a life in the sun. And then, after a few days, the song begins. But it is not the song of 1 or 2 individuals. It is the song of millions upon millions of males, all singing at once. The sound is not just a buzz, it is a wall of noise, a deafening, otherworldly drone that can be overwhelming to the senses. The entire forest, the entire landscape, vibrates with this single, unified, and desperate chorus. This mass emergence and synchronized song is a brilliant survival strategy. It is called predator satiation. By emerging in such incomprehensible numbers, the cicadas ensure that their predators, birds, squirrels, raccoons, any animal that can eat them, are quickly overwhelmed. The predators can feast. They can eat until they are completely full. And yet there will still be millions of cicadas left. It is survival through sheer overwhelming numbers. The loss of a few million individuals is a small price to pay for the survival of the species as a whole. And in this deafening chorus, the females, who are silent, choose their mates. After mating, the females lay their eggs in the twigs of trees, and the cycle begins anew. The adult cicadas, their one great purpose in the sun fulfilled, will live for only a few weeks before they die. Their bodies will litter the forest floor, returning their nutrients to the very soil that sheltered them for so long. So, the next time you find yourself in the midst of that deep, electric buzz of a summer's day, let your mind wander to the story it is telling. Hear it not as a monotonous drone, but as a song of incredible patience and profound urgency. It is the sound of a creature that has spent more than a decade in silence and darkness, all for this one, brief and glorious chance to sing its song in the sun. It is a hymn to the continuity of life, a sound so powerful it can fill the world, a final, desperate, and beautiful act of existence. We have filled our minds with the sounds of the insect world, from the rhythmic, nightly chirp of the cricket to the deep, resonant drone of the cicada. We have come to understand that the air, which can seem so still, is often alive with a symphony of calls, warnings, and serenades. But as true darkness falls, and the musicians of the day and evening begin to quiet their songs, a new kind of conversation begins. This is a language not for the ears, but for the eyes. It is a dialogue written in silent, living light? This is the story of the firefly. Imagine yourself on a warm, humid evening in early summer, sitting at the edge of a field as the last vestiges of twilight fade from the sky. The world becomes a deep, velvety darkness, punctuated only by the distant light of the stars. And then, you see it. A single, tiny spark of greenish-yellow light appears near the ground, hangs in the air for a moment, and then vanishes. A few seconds later, another spark appears, a little farther away, and then another, and another. Soon, the entire field is filled with a silent, twinkling constellation of these gentle, moving stars. This is the magic of fireflies, or lightning bugs as they are also known. It is one of nature's most enchanting and peaceful displays. But this is not just a random, decorative twinkling. It is a conversation. It is a vast and complex series of questions and answers, of calls and responses, all being conducted in a language of light. To understand what they are saying, we must first understand the light itself. How does a tiny insect create its own lantern? The light of a firefly is a form of bioluminescence, a term that simply means living light. It is not a hot light, like the flame of a candle or the glowing filament of a light bulb. A firefly's light is cold light. It is the result of a remarkably efficient chemical reaction happening inside specialized cells in the insect's abdomen. Within these cells, a chemical compound called luciferin. Let's think of it as the light fuel is combined with oxygen. But this reaction will not happen on its own. It needs a catalyst, an enzyme to kickstart the process. That enzyme is called luciferase. The light bringer, when luciferase, luciferin, and oxygen all come together, with a little boost of energy from a molecule called ATP. A chemical reaction occurs that releases energy almost entirely in the form of light. It is an incredibly efficient process, wasting almost no energy as heat. It is a tiny, perfect, and completely cool chemical fire. And the firefly has the amazing ability to control this reaction, to turn its light on and off at will by regulating the flow of oxygen to these specialized cells. So we know how the light is made. But what is it for primarily? It is a language of love, a way for males and females to find each other in the darkness. Let us watch one conversation unfold. A male firefly takes to the air. His goal is to find a mate. As he flies a few feet above the ground, he begins to flash his signal. He is a member of a particular species, and his signal is a specific code that identifies him. His code might be a single, half-second flash of yellowish light, repeated every 5 seconds. He flies and flashes his question into the darkness. I am here. I am a male of my kind. Is there a female of my kind nearby who is interested? He repeats his call over and over, a lonely, hopeful beacon in the night. Now, let us shift our perspective to the ground below. Perched on a blade of tall grass, a female of the same species is waiting. She is often stationary, conserving her energy. She watches the sky, scanning the various flashes of the males flying above. She sees a flash, but its color is too green, its duration too long. It is a male of a different species. She ignores him. She sees another, but its pattern is a quick double flash. Also not for her. She is waiting for one specific signal. And then, she sees it. A male flashes the exact, half-second yellowish pulse of her species. She recognizes her own language. This is a potential mate. But she does not fly to him. She answers him. She waits for a precise interval after his flash, let's say, 2 seconds. This time delay is also a critical part of her species code. And after exactly 2 seconds, she activates her own lantern, flashing a single brief response. Her answer is simple, but it contains all the information he needs. It says, "Yes, I am here. I am of your kind, and I have seen your call." The male, flying overhead, sees her answer. It is the right color, and it came at the right time after his own flash. The Conversation has begun. He now knows her approximate location. He changes his flight path, turning toward her flash. He flies a little closer and flashes his question again. He waits. She sees his new flash, and after her species-specific 2-second delay, she answers again. Her flash is a homing beacon, guiding him toward her through the dark. This silent, luminous dialogue continues. Call and response. Flash and answer. With each exchange, he gets closer and closer, triangulating her position with incredible accuracy, until finally, he lands on the blade of grass beside her. A successful rendezvous, orchestrated entirely through a precise, timed conversation of light. Now imagine the same scene multiplied by 100 or 1,000. The field that seems to be twinkling randomly is, in fact, a busy marketplace of these conversations. Each species has its own unique code. Some flash in double pulses, some flash in long, slow glows. Some, like the famous J-flash fireflies, create a distinct pattern by dipping down and then swooping up as they flash, tracing the letter J in the air. This diversity of languages ensures that, for the most part, fireflies do not get confused. They are able to find and identify appropriate mates of their own kind in a crowd, each speaking their own private language of light. But this world of luminous romance has a dark and deceptive side. There is a genus of firefly, the Photurus fireflies, whose females are known as the femme fatales of the insect world. These large, predatory females have learned the art of mimicry. A Photurus female can watch the males of a different species flashing their calls. She can recognize their code, and then she can imitate the specific response flash of the females of that species, including the precise time delay. An unsuspecting male of the other species, flying overhead, sees what he believes is an answer from one of his own kind. He thinks he has found a mate. He follows the deceptive flashes down to the waiting female, but instead of romance, he finds a predator. The Photurus female grabs him and eats him. She has used her knowledge of a foreign language for deadly deception. It is a chilling and fascinating reminder that, in the world of animal communication, messages can be intercepted and codes can be broken, sometimes with fatal consequences. So, the next time you have the good fortune to witness the quiet, magical ballet of the fireflies, see it with new eyes. Know that you are not just looking at pretty, twinkling lights. You are looking at a complex and vital series of conversations. You are seeing questions being asked and answers being given. You are seeing stories of hope, of romance, of navigation, and sometimes even of deception. You are witnessing a silent symphony, a language written in fleeting, beautiful, and living light. We have listened to the invisible language of scent and the vibrant symphony of sound. We have watched the silent, luminous dialogue of the fireflies. The languages we have explored so far have been, for the most part, direct. A scent means danger. A chirp means, I am here. A flash of light means, I am of your kind. These are messages about the present state of being. But now, we are going to explore a language of incredible sophistication. A language that does not just speak of the present, but gives specific, detailed instructions. It is a language that can draw a map, a language that can communicate distance and direction. We are going to enter the warm, dark, humming world of the beehive and witness the marvel of the honeybee's waggle dance. To begin, let us leave the open fields of the night and imagine ourselves shrinking down, becoming small enough to pass through the tiny entrance of a bustling beehive. The air inside is warm and thick with the sweet, heavy scent of honey and beeswax. The world is filled with a constant, low hum, the sound of thousands upon thousands of wings vibrating, circulating the air. And it is dark. There is no light here to see by. This is a world perceived almost entirely through touch, vibration, and scent. The interior of the hive is a vertical city. Great curtains of hexagonal wax cells, the honeycomb, hang like the walls of buildings. This is where the colony raises its young and stores its precious resources of pollen and honey. And these vertical walls are the stage for our story. They are the dance floor upon which one of nature's most extraordinary conversations takes place. Our story begins with a single, experienced forager bee. She has just returned from a successful flight. She has discovered a treasure, a field of clover, rich with nectar, blooming a half a mile away from the hive. This information is too valuable to keep to herself. She must share it with her sisters so they too can go and gather the bounty. But how she cannot lead them all there one by one. She must give them a map. She must give them precise directions. She finds a small, open space on the crowded, vertical face of the honeycomb, and she begins her dance. The other bees nearby, sensing the vibrations and the scent of clover on her body, gather around her in the darkness, paying close attention. They touch her with their antennae, ready to read the story she is about to tell with her body. The dance has two main parts, and it is a masterpiece of symbolic communication. First, she begins the waggle run. She walks in a short, straight line, vigorously vibrating her abdomen from side to side, her wings buzzing at a low frequency. This waggle is the heart of the communication. Its duration and its angle contain the two most critical pieces of information, the distance to the food and its direction. Let's first consider distance. The length of time the bee performs this waggle run is a direct message about how far away the food source is. If she waggles for only a very short time, say 1 second, it tells the other bees that the clover patch is very close, perhaps only a few hundred feet from the hive. If she performs a longer, more sustained waggle, say, for 2 or 3 seconds, it communicates that the food is much farther away, perhaps the half a mile that she traveled. The longer the waggle, the farther the flight. The other bees, crowded around her, can sense the duration of this vibration. They are, in essence, timing her performance to understand the distance of the journey they must undertake. It is a language of time, a map of duration. But the truly breathtaking part of the dance is how she communicates direction. Remember, it is completely dark inside the hive. There are no landmarks, but the bees have an incredible innate sense of where the sun is in the sky outside, even if they cannot see it. They have an internal clock that allows them to track its path across the sky. And on the vertical dance floor of the honeycomb, the direction straight up is used to represent the direction of the sun. This is the key to her symbolic map. The angle of her waggle run, relative to a perfectly vertical line, tells the other bees the angle they must fly relative to the sun. So, if our forager bee performs her waggle run by walking straight up the honeycomb, she is giving a very clear instruction. Leave the hive and fly directly toward the sun. If she were to walk straight down the honeycomb, the message would be equally clear: fly directly away from the sun. But what if the clover patch is not in line with the sun? What if it is, say, 30 degrees to the right of the sun's current position? Our dancer translates this external angle into an internal one. She will perform her waggle run at an angle of 30 degrees to the right of the vertical sun line on the honeycomb. The bees around her, feeling the angle of her run with their antennae in the dark, understand this message perfectly. They will leave the hive, orient themselves to the sun, and fly at an angle 30 degrees to its right. They have been given a precise bearing, a compass direction, from a dance performed in total darkness. After each waggle run, the bee will circle back to her starting point once to the left, then once to the right, and then repeat the waggle run in the very same direction. This circular part of the dance, the return phase, helps to organize the dance and allows more bees to gather around and get the message. She will perform this entire figure-8 pattern over and over again for many minutes, ensuring that dozens of her sisters have had a chance to read her map. The recruited bees, now armed with this information, fly from the hive. They already know the direction they must travel and the approximate distance they must fly. It is an incredibly efficient system for exploiting the resources of the environment, a way of building a shared, collective mental map of the surrounding landscape within the colony. Let us pause and appreciate the sheer wonder of this. This is not a simple, instinctual signal like a single pheromone or a chirp. This is abstract, symbolic language. The bee is taking her memory of a complex, three-dimensional journey and translating it into a series of highly ritualized, symbolic movements. The duration of a vibration represents the physical distance of a flight. The angle of a dance against the force of gravity represents the angle of a flight against the light of the sun. This is a level of communication that was once thought to be unique to humans. It is data transmission. It is cartography. It is a story, a set of instructions, and a map, all performed by the body of a tiny insect. It is a silent, intricate ballet that feeds a city. We have witnessed the astonishing, symbolic language of the honeybee, a silent ballet performed in darkness that paints a map of the sunlit world. It is a form of communication that is active, complex, and instructional. Before that, we saw the fireflies' dialogue, an active conversation of flashing lights. But the world of visual communication is not always about performance. Sometimes, the most powerful message an insect can send is not in what it does, but simply in what it is. This is a language that is not spoken or danced, but worn. It is the silent, vibrant, and often deadly serious language of color. In the constant, high-stakes world of survival, one of the most common strategies is to avoid being seen at all. This is the art of camouflage. Think of a stick insect, perfectly mimicking a twig, swaying gently with the breeze, or a moth whose wings are a perfect, modeled replica of the tree bark upon which it rests. The goal of camouflage is silence. It is an attempt to blend into the background, to become invisible to the eyes of a hungry predator. It is the language of, "I am not here." But there is another strategy, one that is in many ways the complete opposite. It is a strategy of shouting, not whispering. It is the strategy of making yourself as obvious, as conspicuous, as brightly and shockingly visible as you can possibly be. This is the language of warning coloration, a phenomenon known as aposematism. And it is a bold, high-stakes declaration that says, "I am here, I am dangerous, and you will regret it if you try to eat me." Let us imagine one of the most beautiful and iconic users of this language, the monarch butterfly. As it flutters through a summer meadow, it is a living jewel. Its large wings are a brilliant, fiery orange, traced with bold, black lines and dotted with delicate white spots. It is anything but camouflaged. Against the green of the leaves and the blue of the sky, it is a beacon, an impossible-to-miss splash of color. This beauty is not for the benefit of other butterflies. It is a stark and clear advertisement, a warning sign directed at any bird that might see it as an easy meal. The story of this warning begins when the monarch is a caterpillar. The monarch caterpillar feeds exclusively on one type of plant milkweed. Milkweed plants produce a cocktail of toxic chemicals called cardiac glycosides to protect themselves from being eaten. But the monarch caterpillar has evolved the ability to not only eat these toxins without being harmed, but to store them, to sequester them within its own body. These toxins remain with it through its metamorphosis. And as an adult butterfly, its body is saturated with these bitter, poisonous compounds. Now, imagine a young, inexperienced blue jay. It has recently left the nest and is learning what is good to eat. It sees this large, slow-moving, and brilliantly colored butterfly fluttering by. It looks like an easy and delicious meal. The jay swoops in, catches the monarch, and eats it. But a few minutes later, the bird becomes violently ill. The toxins from the butterfly's body cause it to vomit and feel wretched. It is a deeply unpleasant and memorable experience. And in that moment, the blue jay's brain forges a powerful and permanent connection. It learns to associate the specific, brilliant orange and black pattern of the monarch butterfly with a feeling of sickness. The lesson is learned. The next time the blue jay sees a monarch, or any other butterfly with a similar pattern, it will not attack. It will ignore it completely. Remembering the terrible experience? This is the genius of warning coloration. The sacrifice of one monarch has educated the predator, ensuring the future safety of many other monarchs. The bright, beautiful colors are a visual mnemonic, a memorable brand for poison. The butterfly is shouting its toxicity with its wings. We see this language all around us in the insect world. The common ladybug, with its bright red or orange shell and black spots, is using the same strategy. It is advertising the fact that it produces foul-tasting, defensive chemicals. A bird that eats one will find it so distasteful that it will avoid that familiar red and black pattern in the future. And perhaps the most universally understood of these color codes is the stark, alternating pattern of yellow and black. We see it on wasps, on hornets, on many species of bees. This is not a signal for "I taste bad." This is a signal for "I can cause you pain." The yellow and black is a universal symbol for the presence of a sting, a sharp, venomous weapon. Most predators, and indeed most humans, have an innate or quickly learned aversion to this pattern. It is a visual representation of a threat, a silent buzzsaw of color that warns everyone to keep their distance. This system of honest advertising is so effective that it has, of course, invited forgery. In the great evolutionary game, if there is a successful strategy, someone else will find a way to copy it. This leads to the fascinating phenomenon of mimicry. Let us first consider a harmless and common insect, the hoverfly. It looks remarkably like a small bee or wasp, with a stout body and bold yellow and black stripes. It buzzes from flower to flower, feeding on nectar. But the hoverfly has no sting. It is completely defenseless. It is, in essence, a master of deception. It has evolved to look exactly like its dangerous neighbors. This is called Batesian mimicry, where a harmless species copies the warning signals of a harmful one. A predator, like a bird, having once been stung by a real wasp, will now avoid anything with that yellow and black uniform, including the harmless hoverfly that is simply bluffing. The hoverfly is wearing the uniform of a dangerous army it does not belong to, and it gains protection from this act of identity theft. But there is another, even more subtle form of mimicry. Sometimes multiple different species, all of whom are genuinely dangerous, will all evolve to look like each other. Many different species of stinging wasps, for instance, share very similar patterns of yellow and black. This is called Mullerian mimicry. This is not deception, but cooperation. It is a form of mutual advertising, by all adopting the same shared warning label. They make the lesson for predators easier to learn. A bird only needs to be stung once by any member of the yellow and black club to learn to avoid all of them. It strengthens the signal, benefiting every species that participates in the mimicry ring. It's like several different companies that all make dangerous products agreeing to use the exact same, universally recognized warning symbol on their packaging. So, the colors of the insect world are a language of their own. It is a silent, visual dialogue about risk and reward, about danger and defense. It is a language of honesty, where the monarch truthfully advertises its poison. And it is a language of lies, where the hoverfly cleverly wears a disguise. As you walk through a garden, know that you are walking through a gallery of these signals. The colors you see are not always there for your aesthetic pleasure. They are urgent, shouted messages, a constant and silent negotiation of survival, painted directly onto the beautiful, fragile wings of the insects themselves. We have explored the grand, public languages of the insect world. We have followed the invisible highways of scent, listened to the vibrant symphonies of sound, and watched the silent, luminous dialogues of light. These are the languages of long-distance communication, of broadcasting a message to the world. But now our journey must turn to a form of communication that is far more intimate, more personal, and, for many social insects, the most important language of all. This is the language of touch. For us, touch is one of our 5 senses. But for an insect like an ant, living in the crowded, dark, and complex world of the colony, Touch is a fundamental part of its reality. In the darkness of the nest, sight is useless. Sound, in the way we think of it, plays a minor role. The world is perceived and navigated primarily through a constant, complex, and subtle conversation of chemical sense and physical contact. And the primary organs for this conversation are the two beautiful, delicate, and constantly moving antennae. We have spoken of the antennae as an insect's nose, a sophisticated tool for detecting the pheromonal messages on the wind. But they are just as much an insect's hands. They are flexible, jointed, and covered in thousands of tiny sensitive hairs and receptors that can feel the slightest pressure, the most subtle texture, and can simultaneously taste and smell the chemical world. The antennae are a combination of fingertips and tongue, constantly exploring, questioning, and reading the immediate environment. And when one ant's antennae touch another, a conversation begins. Let us return, in our minds, to the entrance of the ant nest we visited earlier. It is a place of constant traffic, a busy doorway to a hidden city. And at this doorway, there are always guards. Their job is to ensure that only members of their own colony are allowed inside. But how can they tell friend from foe? An ant from a neighboring colony of the same species looks identical. There are no uniforms, no visual cues. The identification is made through a ritual of touch. Imagine a forager ant, one of our own, returning from her journey. As she approaches the nest entrance, she is met by two guards. They do not recognize her by sight. They approach her head-on, and a rapid, intricate dance begins. The guards begin to tap and stroke her body, her head, and especially her own antennae with their antennae. This is a process called antenation. It may look like a chaotic flurry of movement, but it is a systematic and thorough inspection. What are they looking for? They are reading her chemical signature. Every ant colony has its own unique colony odor, a specific blend of chemicals called hydrocarbons that covers the outer layer of each ant's exoskeleton. This scent is like a passport, a national flag, a secret family handshake. It is acquired by all members of the colony through constant grooming and food sharing, so everyone smells the same. As the guards tap her with their antennae, their own chemical receptors are tasting her scent, comparing it to the familiar scent of home. If her scent matches, if she has the correct password written in a language of molecules on her skin, she is recognized as a sister, a nestmate. The guards will part, and she will be welcomed inside. The entire interaction might take only a second, a brief, fluttering confirmation of "you belong." But imagine a different ant, one from a rival colony, trying to enter the nest. She approaches, and the guards meet her with the same ritual of antenation. But as they touch her, their antennae detect a foreign scent. The chemical password is wrong. The message their senses receive is not sister, but stranger, intruder. And the response is immediate and aggressive. Alarms may be spread, and the intruder will be fiercely attacked and driven away, or killed. The survival of the colony depends on this chemical and tactile security check. It is a conversation about identity, about belonging, about the fundamental distinction between us and them. This language of touch is not only for security, it is woven into the fabric of daily life inside the nest. Let us follow our successful forager as she moves deeper into the dark tunnels. She is now surrounded by her sisters. Some are tending to the young, others are excavating new chambers. One of her sisters, who has been working inside the nest, approaches her. This sister is hungry. She can smell the food that the forager has recently eaten. She begins to gently but insistently tap the forager's mouthparts and head with her antennae. This is not an aggressive act. It is a solicitation. It is the language of asking. The tapping is a clear request that says, "I am hungry. Please share what you have." In response to this tactile plea, the forager bee will often stop and regurgitate a small droplet of liquid food from her social stomach. a special crop where she stores food to share. The hungry sister eagerly accepts the meal. This process, called trophallaxis, is the social glue of the colony. It is a communal digestive system that ensures all members, even those who never leave the nest, are fed. And the entire vital transaction is initiated and mediated by this gentle tapping language of touch. There are even more complex conversations that can happen through touch. Imagine a scout has found a new, much better location for a nest. It may be too far, or the path too complex, to be communicated by a simple pheromone trail. She needs to physically guide another ant there to confirm that the new site is suitable. She does this through a behavior called tandem running. The lead and the scout begins to walk toward the new nest site. The follower ant walks directly behind her, keeping her antennae in constant contact with the leader's abdomen and back legs. This constant touch is the entire conversation. The follower is saying, "I am still with you. Continue." If the follower gets separated and loses contact, the leader will stop and wait patiently until the follower finds her again and reestablishes the tactile link. It is a guided tour for one, a slow, deliberate journey where the map is communicated not by scent or sight, but by the continuous, reassuring presence of another's touch. For an ant, to live is to be in a constant state of tactile communication. It is a world of gentle, stroking greetings, of rapid, questioning taps, of solicitous requests, and of reassuring presence. It is how they recognize each other, feed each other, guide each other, and work together as a single, cohesive unit. The constant hum of antennal conversation is the sound of their society functioning. As you lie here, feeling the gentle pressure of the blankets on your own skin, think of this world of touch. For us, language is primarily sound and sight. But for the ant, and for many other social insects, language is a physical, intimate, and immediate thing. The ghost on your skin, the goosebump, is a fleeting, involuntary touch-based sensation. But for the ant, the world is a continuous and voluntary series of goosebumps, a rich and detailed story told by the constant, gentle tapping of 1,000 sisterly hands. It is a reminder that communication can be as simple and as profound as a direct connection. Our long and quiet journey into the hidden world of insect communication is now coming to a gentle close. We began by listening to the familiar sounds of a summer night, and we have since discovered that those few audible notes are but a tiny fraction of a vast and complex symphony being performed all around us. All the time, we have learned to perceive the world in a new way, to understand that the air is never empty, and the silence is never truly silent. Let us, for a final time, reflect on the path we have traveled, on the secret languages we have learned to recognize. We began in the world of scent, the most ancient and widespread of all insect languages. We followed the ant, our steadfast guide, as she wrote a map upon the ground with her own body, a fragrant, invisible road made of pheromones that led her sisters to a treasure. We then took to the air with the moth, witnessing a long-distance romance conducted entirely on the wind, a love letter written in a language of single molecules, read by a pair of magnificent, feathery antennae across miles of darkness. We understood that the very air we breathe is a medium for invisible words, for silent conversations of warning, of invitation, and of love. From the world of silence, we moved into the world of sound. We found the cricket, the familiar minstrel of the night, and learned that he is not rubbing his legs together, but playing his own wings like a miniature instrument. We learned to distinguish his different songs, the loud, hopeful call for a mate, the soft, persuasive courtship serenade, and the sharp, aggressive duel with a rival. We then felt the deep, resonant hum of the cicada, a sound produced not by friction, but by a pair of powerful drumming membranes. We heard its song not as a monotonous drone, but as a desperate, urgent hymn to life, the culmination of a 17-year-long silent waiting period beneath the earth. We learned that the sounds of summer are a complex social drama, a symphony of purpose and meaning. Our journey then took us into the realm of sight. We watched the gentle, magical ballet of the fireflies and understood that their twinkling was not random, but a precise dialogue of light. We saw the male's flashing question and the female's timed, specific answer, a silent conversation that allows them to find each other in the vast darkness. We saw how this language of light, so full of romance, could also be used for deadly deception. We then witnessed one of the marvels of the natural world, the honeybee's waggle dance. Inside the dark, vertical city of the hive, we saw a single bee perform a complex symbolic map, translating distance and direction into a ritualized dance, telling her sisters precisely where to find a field of flowers in relation to the sun. It was a moment that revealed a level of abstract communication, of symbolic language. That is truly astounding. We saw how language can be worn in the brilliant, bold colors of the monarch butterfly and the ladybug. We learned that these beautiful patterns are not for us, but are a stark, visual shout to predators, a language of warning that says, "I am poisonous, I am foul-tasting, do not eat me." We saw how this honest advertising has led to a world of mimicry and deception, where harmless flies dress up in the uniform of dangerous wasps. And finally, we returned to the most intimate of all languages, the language of touch. We entered the ant colony and felt the constant, fluttering conversation of antennae, a language that confirms identity, asks for food, and guides a sister on a journey. We understood that for many creatures, society is built and maintained through a constant, reassuring, and deeply informative physical connection. Each of these channels scent, sound, light, movement, color, and touch is a different section in a great, unheard orchestra, and they are all playing at once. As you lie here now in the quiet of your room, try to imagine the world outside not as you perceive it, but as it truly is. Imagine a garden at night. The air is filled with the drifting plumes of moth pheromones, a dozen different invisible love stories unfolding simultaneously. On the ground, several different species of ants are following their own distinct chemical maps to different food sources. In the grass, hundreds of crickets are each conducting their own private dramas of courtship and territory. In the air above, fireflies of different species are flashing their unique codes, their silent questions and answers creating a complex twinkling web of light. On a milkweed plant, a monarch caterpillar is storing the toxins that will one day be advertised by its brilliant wings. And in the soil beneath, the cicada nymphs are silently waiting for their year to sing. The world that seems so peaceful and still to our large human senses is, in reality, a city that never sleeps. It is a riot of information, a constant, high-stakes, and beautiful exchange of messages. It is a reminder that our perception of reality is just that, our perception. It is a narrow slice of a much broader and more complex spectrum of existence. There are entire worlds of communication, of drama, of life unfolding in channels we are not equipped to sense. To know this is not to feel small. It is to feel a sense of profound wonder. It is to understand that the world is so much richer, so much more intricate than it appears. It is to feel a connection to the vast, teeming, and communicative web of life that we are a part of, even if we cannot hear most of its music. Let that feeling of wonder be your final thought tonight. Let the idea of this unheard orchestra be your lullaby. The world is not empty. It is full. It is full of secret stories, of silent songs, and of languages waiting to be understood. And you are safe, resting in the midst of it all. There is nothing more to learn, nothing more to explore. There is only the quiet of your own breath, a gentle rhythm in a world that is humming with life. Rest now and sleep.